Hi, in this assignment, we are going to be walking through how to connect to the Pokémon API to then get Pokémon data to do basic exploratory data analysis on it. Now, before we actually dive into the code, I do want to give a brief overview at a high level of what we are going to be doing with the code, so you kind of have an idea of where we're going. And also, I just want to say straight up, I think the Pokemon dataset is one of my favorites to use with machine learning, just because of how rich the different features are in it. You get your basic quantitative variables with stats, but you also get categorical variables that you can look at, which is great. It also has text descriptions for each one of the Pokemon, which is awesome to run natural language processing on to look into analysis for that. You also can access images of it. So if you want to run any kind of image classification, it's just overall, I think, a really fun data set to work with. And when you do find insights from this data set, it's always fun to then be able to go off to, if you have a friend or something that plays Pokemon, you can actually give them advice, which makes it a little bit more grounded than some of these other more abstract data sets that we work with, like looking at different flower types or different cars. But so just at a high level, also I do want to say one thing about APIs. The usually with an API, the hard part is not necessarily connecting to the API. That is usually the easy part with it, given that you have the right credentials. The hard part with an API more often than not is dealing with semi-structured data. We talked about in the previous lecture the differences between data. You have your structured data that's in tabular form, that's really quick to pull out to do analysis on. Then you had semi-structured data, which is usually in like key value paired form. And while that's great because it's a little bit it's more flexible and can be faster sometimes. Um, the problem with that is you have to translate that back into tabular form to do analytics on it. And that is what the majority of this assignment is going to be going over, is how to take that JSON file that we're going to receive, that is going to be in a value paired format, and then turning that key value pair format into a tabular data frame that we could actually do analytics on it. So first, we're just going to kind of hit the API to see what comes back. If we look at the API really quickly, you see that we get about a list of 20 different Pokemon. We get a name, and then we get a URL. If we click on this URL, that will give us all the data on the Pokemon in JSON form. So then what we want to do is we want to first start off, we want to be able to get a single row of our data frame. So we're going to play around with that, and we're going to use the name and the URL as inputs. So we have our name and our URL, and those are going to be our inputs. From that, we are then going to be able to get the base stats for that Pokemon in JSON form, as you can see here. And then we are going to go through those base stats, and we're going to create an empty data frame just so we can get a single row with these stats in it, and we're going to make a loop that goes through the JSON file or the dictionary and then populates the data frame with the stats. So we then end up getting a single row that looks something like this, where we have our Pokemon as our index and then the different stats for that Pokemon. Then we're going to turn that into a function. And what's great about having a function is once we have all this in a function, then we have this get data function where all we have to do is enter a name and a URL, and then that'll return us with a row. After that, we want to be able to get this entire batch. And so what we're going to do is we are going to first we want to turn this dictionary into just a list, iterate through all the names and the URLs so we can plug it into our get data function. And so we are going to create a new empty data frame called batch df, and then we are going to iterate through all the results, and then we are going to get the name and the URL for each result, and then we're going to plug that into our get data function, which is going to return a single row of a data frame, and we're going to stack that on using the concat function to our batch data frame. And what this results in is a data frame of this entire batch. Now with APIs, I'll explain this in greater depth, but as you can see, we only get about 20 results from this one hit. And what we want to do is we want to then go to this next URL, which will get us our next set of results. And then you can see this next this set of results provides us with another new URL that will get us our next set of results, and you can see how the Pokemon's name changed as we go from results through as we continue on to the next. And so you kind of think about this as like flipping pages in the book, and this tells you the next page to get. So we want to create some kind of loop that will flip through all these pages, and then run our batch and run this batch function that we just created, a batch function that we created down here so that we can get all the Pokemon. So we'll create a loop, we'll have this, we'll create our ultimate data frame that will hold all of our Pokemon called Pokemon, and we'll just keep that as a blank data frame. Then we'll set our next URL to the first URL. We'll have this Boolean called stop, and we'll set that to false. And while stop is true, while stop is not true, what we'll do is we'll run through this loop. This loop, it's going to try to get the next page and then return that as a JSON file. If it fails to get the next page, it will then go to this except statement. The reason this would fail is when it gets to the last page, there's not going to be any more pages for it to get, so it's going to stop. And when it fails, then we're going to set stop to true, and we're going to break out of the loop. If it doesn't fail though, what we're going to do is we're going to run the batch function that we made up there to get, that will return about a data frame of about 20 Pokemon from that page, and then we're going to concatenate that and stack that on our Pokemon data frame that we created up here. And it's going to loop for that. This function takes a long time to run. As you can see, it goes through a lot of pages. And then we'll finally end up with this data frame that's about 1,200 rows, almost about 1,300 rows long of every single Pokemon that exists with all their different stats. After that, we'll do simple exploratory data analysis on it. Now, I just want to make this very clear. This assignment is about trying to work with APIs and learning how to work with that. I want that to be your focus on this assignment. This exploratory data analysis, you're completely free to do whatever you want. And even you can copy the charts even if you want to, just straight from here. Really, I want you to get familiar with working with APIs. But just running quick through what the exploratory data analysis will look like is we'll look at some things about we'll look at some features of the different stats. Then we'll go ahead and normalize the data so we can better compare it. Then we'll draw some insights from that and turn that into a CSV file that we can then put into our PowerPoint slide. But that is the quick overview of what we are going to do in this assignment. Okay, now we're going to jump into building out this API. And I'll just give you a fair warning, this is going to be quite the process. However, if you get good at doing this, I promise you, you'll never be unemployed. You'll always be able to find employment if you're good at building out APIs. And so let's start off by first, we're going to create a new section. We are just going to call it Pokemon API. Okay, we'll close this section down. Here we'll start to add some code. First thing we'll do, as always, is we'll import our standard libraries that we're going to be using. So we'll import pandas so we can manipulate data frames. We'll then import requests so we can get things from the internet or access the internet. We'll import JSON so we can convert text files. So we'll start off with that. Then we will want to get our URL. And this is going to be our URL that we're going to be using. Really quick, I'll show you what that, let's go to the API or the website and explore it. So the way this works is essentially you can type in whatever Pokemon that you want, and then you will get a specific, and then you'll get all the information for that Pokemon. So if we just go to this website, or you'll see that we get a JSON file with a list of different Pokemon and a URL. If we click on that URL, that will then take us to a different JSON file that will give us all the information we could ever want to know about this Pokemon. So going back to our code, so we established what our URL is. We're then going to want to get a response. Using request, we want a get response, and then we're going to be referencing that URL. And we get a response 200, that means we're good to go. Now we want to get the text of this response. We can do that. We then want to convert this text so it's in dictionary form. So we'll do JSONs load, and then that turns it into dictionary format so we can easily play around with that. And there is our data that we have. So we want to start out with trying to get a single, Pokemon. It's because we want to start with a single row. So I'm going to make a new text header. Just call this a single Pokemon stats. Okay, so let's look at our two inputs that we want to use. We want to use name because from this file we can get a list of all the names and a list of URLs. So that is going to be what we want our inputs for our function to be. So we want to have a name, and I'm just going to take this first entry, Bulbasaur. I'm going to set that as our name, and then for our URL, I am going to get Bulbasaur's URL. And I want to point out there's a lot of different ways to go about this process. You may have noticed that there's a 1, then there's a 2, then there's a 3. So one shortcut to getting around all this could be you just make a loop. That adds an integer that increases each time. The specific reason why I'm doing it this way and the way I'm going to be doing this moving forward is I want this API script to be as robust as possible, meaning I want it to be that if anything changes on the backend, if they decide to change the way they do their URLs, or if they change features, or if anything changes on the backend, that is not going to break all of my connections in the future. So yes, there are quicker ways to do this, but I'm going to be walking you through and showing you how to do this from a best practice data engineering standpoint to try to make this API call as robust as possible so it will not break. I'm also doing it in a function format where we're going to be having a function within a function. And what's really nice about doing that is it makes it very easy to change things and also to run jobs, because then all you have to do is run a function. But getting back to getting this single Pokemon stat. So we want to get the request. Want to get a request from it, and then we want to get the data from that response. And so let's see what that pulls up. And as you can see, we have a lot of data that we can pull from this Pokemon. We can look at, here's all the different games it's been in. We can look at the different moves it has. We can look at when it learns those moves. A lot of different things we can extrapolate from this. We specifically, though, want to find stats. And we can see that the key for that is stats. And that gives us our base stats, our attack, our HP, our defense. That's ultimately what we want to get. So I'm just going to close that down. And so if I call that key on the dictionary and run that, you can see that it returns all those stats for me. So now we want to figure out how we can really, we want to start to, we want to start playing around with this a little more. So let's set this equal to, we're going to call this stats and set that equal to there. Now, if we explore stats a little bit, okay, we can look at like the first index of stats. You see, okay, I get the base stat, I get the stat value, we get the effort. Don't really care about the effort right now. We do get the stat name, HP, which is something important that we do want to get. And we get this URL. That just describes even more information about this stat if you want to. We're not interested in that. So really, we are just going to be looking for how can we get this number and this name from this data. So what we can do is we can go ahead and we can say that the actual stat is equal to stats 0, and then what do we want to, or what do we want to call? We want to get the stat name, so we'd first use the key stat. And let me print that so we can see what happens. And so then we notice that we get this, and there we get another dictionary. So we need to call, if we want to get HP, which is the name of that stat, we'll have to use the name key to get there. And we get that, you see we get HP. So that gets us the stat we want. Now we want to get the value of that stat. So for value, we can do stat, and it looks like all what we have to do is call base stats. So I'm going to take base stats here, plug that in, print that out, and then value. So there we go. We can get now we have this variable that gets us the stat name and this variable that gets us the value of the stat. And we can replace that 0 with n. If we run that, You can see it still works, and then we can put whatever number we want in there, and it will get us all the different stats that we are looking for. So this is going to be important when we go about to build our loop. But first, before we do that, we want to create an empty data frame. So I'm just going to call this df temp, and this is going to be our row that's going to hold all of our stats. Index, and we'll set the index equal to name. We already defined name up here. Let me see. Oh, so when you pass in an index, it has to be within a list. There we go. And now we have our empty data frame. So there's nothing there, but we have something we can populate. So I'm going to pull all of this down, and I'm just going to change this n to I and that I means index, and that's going to keep our loop going. Now, like I said, I want to make this as robust as possible. So I'm pretty sure that Pokemon are going to only have so many stats, but in the case that the database decides to add more, or the stats that the Pokemon currently has, I'm only going to assume that there's those current stats of speed, attack, defense, HP, special defense, and special attack. However, maybe they might want to change it in the future, and in the case they decide to add a stat or drop a stat, I want to build an API that can accommodate that. So what I'm going to do is I am going to create this Boolean here called more stats, and I'm going to set that equal to true. And what that basically means is instead of saying I want these specific stats, it's going to iterate through all the possible stats that the file has. And this is just telling me when there are no more stats to add. So then I'm going to create my while loop that's going to look at while more stats is true, it is going to try to pull these stats. And then we want to take this empty data frame that we made, and we are going to then make a new column, and that column is going to be equal to the stat name, and set that column equal to the stat value. And then, and if a stat does not exist at that index, we are going to create an except statement that will set more stats equal to false. That will stop our loop. Finally, we want to have our index to iterate. So we'll do 1 plus 1. And I guess if we want, we can include these print statements in here just so we can kind of see what's going on. And so you see it iterates through all the different stats. And if I then take our data frame that we created, you see we get a single row that has all the different stats. So now this is awesome. What we want to do is turn this into a function. So let's go through everything that we did here. We had this piece of code. So I'm going to paste all this code in. I'm going to take off these print statements. And also just want to let you know, when you debug, print statements like this are an excellent way how to go about debugging. Now, before that, we had this empty data frame that we wanted to create, so that's also really important. And then lastly, we want to come up here and get this, which will take our URL and it will get us the data that we want to get. So I'm just going to group these sections together a little bit. And then what I'm going to do is I'm going to create I'm going to define a function, and I'm going to call that function getData. The input parameters are going to be name and URL. And then I am going to tab this over one. And then make sure that it returns this data frame here. So we can then test out this function. I'm going to take these names down here, and then I'm going to use our get data name URL, and if I run that, there we go. That function right there returns a single row. Now that we have a function that can return a single row, we want to get the batch. So I'm going to make a new section, batch of Pokemon stats. Okay, so let's go back up here again. Let's bring this down just so we can see again what's going on at this level. Okay, so that's what we get now. And we have this really nice function here that will get us a single row of our data frame. So now we got to figure out a way how we're going to get names and URLs. So if we look at data, we see that we have these different things that we can call. We have something like count that returns a number. We have next that will give us the next page with the next batch of Pokemon. But what we want is something in here called results. So we are going to call the results key, and that is going to give us a name. That's going to give us the list that we want to get. So I am going to then call this results. We're going to set that equal to there. That. And so if I then go ahead and run this, we get all of the results that we want. And then you can notice if I do results, if I look at the first index of results, the first thing in the list, I get a name and I get a URL. And then I can call the keys for that. So if I want to get a name, I call name. And if I want to get a URL, I call URL. So that will give us what our two inputs need to be. If I create a for loop for result and results, so this is going to iterate through every single list, I can just print result. If I run that, that prints out my results for me. So what I'm now going to do is I want to create a empty batch data frame. Okay, now I want to want to get a name. So I'm going to say name is equal to results name, and then URL is equal to results your URL. I used the wrong brackets here. Apologize about that. And so what should happen is that will get me my names and our URLs. Oops, put an S on that. There we go. So that gives me all the names and the URLs that I'll need. Then I can go ahead and I can use a concat function. I want to concat if I print out, before we get to that, if I do get data, if I use the function I made and I enter name and I enter URL, you'll see that I get a list of all the different rows. So what I want to do is I want to add all these rows to this data frame and stack them on top of each other. So I'll take our empty data frame that we have here, and then I'll use a concat function. And concat, what it does, it's identical to a union function in SQL. It will say it wants me to get a list of data frames, and then it's going to stack those data frames on top of each other. So the first instance in the list I want is our batch data frame, and then our second instance in the list I want is our get data, the row. So every time it runs this loop, it's going to get a new row and stack it on the previous ones. And I can go ahead now and run this loop. And you can see, there we go. Now we have our batch. And so of course we want to turn this into a function. So the way we're going to do this is I'm just going to copy this. I'm going to create a new I'm going to define a new function to get batch, and then we will import, the parameter will be results. And tab this so it's all lined up. And then we'll want it to return the batch. So this, we're going to enter in the results of a page into this function. And if we do so, it should give us a whole batch of Pokemon. So we'll run that function and we can go ahead and test this out. Pull all of this down. So that is our first page there. And if we get the results, if we do, we'll call results from this, and then we can use our batch function to get batch data. We run that, and there we go. We get an entire batch of Pokemon. Okay, we are almost there, so close. So I'm going to make one last section. I'm just going to call this section all Pokemon stats. Okay, and the way this is going to work, let's take all of this back down because we're going to eventually use it again. So what we want to do is we need to create some kind of function that is going to iterate through each one of these URLs so that we can get every single Pokemon. And just if you're curious why this happens, it's a way to limit data requests. You might also, sometimes there's parameters that could allow you to change the limit. You see up here, it says limit 20. If I change that to limit 100, I get 100 Pokemon instead of just 20. Look, if I change this to limit 1000, I get 1000 Pokemon instead of just 100. So that is a shortcut to doing this. However, most of the time, from what I've seen, you'll be limited to anywhere between 100 to 400 results, and sometimes you're pulling thousands and thousands and thousands of rows of data. So the ability or to know how to iterate through, knowing how to iterate through pages like this is important. So let me set a couple things up. First, I will want to get what that next URL. I want to have a variable called next URL. And just for right now, I'm going to set that to our current URL. Then I want to have another variable called stop, and we'll start that as equal to false. And so then I'll do while, then I'll make a while loop while not stop. What we're going to do is we are going to connect to, instead of URL, we want to connect to next URL. And then we want to get the data for that next URL. However, what's going to happen is when we run this, it's going to, so we're going to get, so I'll come back to that later actually. So that will get us the data we want. We also now want to have a data frame that will contain all of our Pokemon. So I'm going to make an empty data frame up here called Pokemon DF. And I'm just going to set that equal to an empty data frame. So now what we can do is we can concatenate the Pokemon data frame. We'll do something identical to what we did up here. So we want to concatenate each one of these data frames on top of our Pokemon data frame. So Pokemon df equals pandas.concat, and then we are going to enter our list of data frames. So our first data frame is going to be our total data frame, and then after that we want to get the data frame that will be our batch. So we put this in, and I can run this. However, what's going to happen is it's going to get to the last page, and there's not going to be another page for it to go to, and this whole thing is going to break. Or actually, wait, first, before that happens, I would have to set our next URL equal to data.next. And what I'm doing is I'm calling this key right here to get this URL. So then that's going to change what our next URL is. So this loop is going to first go through our first URL. It's going to concatenate its first batch on this empty data frame. Then it's going to get the next URL. It's going to pull the next batch and add it on to the previous batch, get the next URL, so on, so on, so on. However, once it gets to the end, there's not going to be any more pages for it to hit. So it is going to get an error. So the way we're going to prevent that from happening is we're going to use our try statement. And so our try statement will try this, and if this doesn't work, then we'll have an except where I am going to set stop to true, and then I'm going to break out of the loop. And the reason I'm doing this is because sometimes with this specific data set, the last URL, it just returns none. So normally what I'd do is I'd put my try function down here, and I'd try to get this, and normally it just won't have, or not normally, but every API is different. The APIs that I've been used to working with, they don't return everything. They don't even have a next on the last page. And because of that, this usually gets an error, and that's where I put the stop, and I put the stop right there. However, in this case, since it's up here, even if I do set stop to true, this will still try to run and I'll get an error, so I want to break out of the while loop. There's many different ways to go about doing it. I just like to use a stop boolean. You don't necessarily need to, but you just need to make sure you have some way that you are breaking out of this function. Lastly, just to kind of see what is going on, I'm going to print out what the next URL is, just to make sure that we are actually making progress. Everything looks lined up. And I'm going to go ahead and run this. What is this? Okay, I need to have quotes around next. Okay. And as you can see, this is iterating through all the different URLs. That means we are getting each row, it's getting each batch, and it's stacking that on top of each other. Depending on how long this takes, I might just cut this out of the video, because think of this as almost like a download, and this can take a while sometimes. Okay, and there we go. That took 1 minute and 25 seconds to complete. And you can see the last next URL, it just returns none. But now if I go here and I go to Pokemon DF and I go ahead and run that, now we have a data frame that has almost over 1,300 different Pokemon in it. And we are ready to do our data analysis on it. Okay, so now that we have all this Pokemon data we can work with, we are now going to hop into the exploratory data analysis. So I'm just going to make a new section. I'm going to call this Pokemon EDA. Move this down here. And really quick, before we get into this, I just want to reiterate, if you are unfamiliar with working with APIs, I want your main focus on this assignment to be understanding what we did up in this portion. You do not have to put in much effort into this portion. I'll be walking you through, I'll be pointing out different examples of just what things are acceptable to turn in. However, I know for quite a few of you, you are very familiar with working with APIs, and what we just did may be very easy to you and be very familiar. So I do want to go in a little bit more depth in this section, and I'd want you guys to focus more on your data analysis portion if you do find APIs to be if you do find the APIs to be pretty easy. But remember, this assignment doesn't count for much, and I don't want you guys spending too much of your time working on it. So we have this data frame that we have. One of the first things we can do is simply we can just describe it to look at stats. This doesn't necessarily tell us too much just because we have so many records here. You can see standard deviations are all pretty similar. The memes are pretty similar for all the different stats. That's a little bit interesting. But let's really get into let's bring up the pair plot so we can better investigate this data set. So I'm going to import Seaborn as SNS, and then I'm going to import matplotlib my plots as PLT really quickly. I'll just make sure that runs fine. And then I'll make my pair plot. And I'll just enter my data frame in here. And then I want to look at that pair plot. Okay, and this is going to take a while to run just because there's so much data we're looking at. Remember, this data set is 1,279 rows. So let's give that a minute to load. Okay, there we go. And okay, I want to look for correlations, but one of the first things I see about this data is if I look at most of these plots is that they all seem to be highly correlated with each other, which doesn't really tell us that much. And you would think that different stats shouldn't be highly correlated, or not, they're not highly correlated, but we see positive correlations, and I would be expecting negative correlations between different things. For instance, if a Pokemon had really high attack, then it's only intuitive that its defense would be a little bit lower. But that's not what we're seeing, is we're seeing there's actually a strong correlation between defense and attack. So why is this? Well, you think about it, there are strong Pokemon and there are weak Pokemon. So a weak Pokemon will naturally have lower HP stats, it'll have lower attack and defense and speed and all that. And a strong Pokemon will have relatively higher HP and attack and defense stats. So all what this graph pair plots is really telling me is that as um as Pokemon get stronger with one of their stats, their other stats are more likely to get stronger, which really isn't that insightful. So what I want to do is I want to normalize the data, and normally we normalize data down on columns. However, in this case, I want to normalize the data across rows. And really quick, if you're unfamiliar with normalization is, think about it like this. When you take a standardized test, you get a percentile back. If you get in the 50th percentile on taking a standardized test, that means you were right in between, you were dead average. So what the percentile is, it's a way of standardizing the standardized test. So say like if you take the ACT and the SAT, well, it's hard to compare the score of say like a 25 or a 30 on the ACT to a score of a 1880 or like 1000 on the SAT. The 1000, like the SAT is so magnitudes higher than the ACT. So how do you compare it? You'd standardize the two into percentiles, and that would allow you to compare what a comparable ACT score is to an SAT score. So that's a really quick lesson on what normalization is. I'm going to be normalizing every row. So essentially, I'm going to be looking at what is the competitive advantage, or like what stat does this Pokemon have a competitive advantage in compared to its other stats. So I'm going to create a normalize lambda function, and you do not need to know like what a lambda function is, or really You do not need to use this for your assignment if you don't want to or you find it too complex. I'm just happening to do this for this analysis. So lambda function allows me to apply this function across rows. So given an x for an array, it will import an array, and x is a value, but it's also a row, and it's also a row of the array. So what I'm basically doing is, given a certain stat, I'm going to take the value of that stat and divide it by the sum of all the other stats. And what this does is it basically will give me a percentage of how much, if I had, say, like 100 points to give for each stat, this is what the distribution of those stats are going to be. It's going to make more sense in a second, but I'll show you what it'll look like. So I'm going to make this new data frame called Pokemon Norm or Normal, and I'm going to take our original Pokemon data frame, and then I'm going to use an apply function. And I'm going to use the apply, and I'm going to apply the lambda function that I declared up there, and I want to apply it to axis 1 because that's the row axis. And so if I run that, oops, I need to run this first. If I run that, okay, so what you need to know is all of these numbers should add up to 1. So if I'm interpreting this now, I see that special attack makes up about 20% of Bulbasaur's stats, and special defense makes up about 20% of its stats, where 15 were speed, defense, and attack and HP. They all individually make up about 15%. So from looking at this, I can say that Bulbasaur has a competitive advantage in its special attacks and defenses, since that makes up about 40% of its stats distribution. And so now let's go ahead and try to run a pairs plot analysis on the standardized data frame. So I'm going to look at that. That's going to take a second to run. Okay, now that we have it. Okay, there we go. Now we have, it's still, the data is very much spread, but we are starting to see different things, like, for instance, defense here and special defense here. We're seeing a pretty strong correlation for some of the data. Other the data is spread out, that's a little bit interesting. But same thing with attack and special attack. We also see there's some correlation going on there. It's kind of interesting. We're seeing this X shapes. So kind of like, I guess the interpretation of this is a Pokemon either has its special attack and special attack and attack are highly correlated, or they're not correlated. But that is definitely to be more expected. We see over here its special attack and its HP are pretty heavily non-correlated. In fact, we see that as HP increases, speed heavily decreases. So that's an interesting insight we can look at. You look at here. I like this insight. We see that we have defense, and what is this? This is speed. So we see a pretty good correlation, a negative correlation between defense and speed. And just for fun, let's look at our non-normalized data frame. And yeah, we kind of see that here. We do kind of see that there is this negative correlation between defense and speed. But when we normalize the data, it really makes it a lot more clear that there is a negative correlation between defense and speed. So that is the insight I am going to talk about on my slide. Now, when you guys turn in your assignment, if you choose to use this API for your assignment, you will have to choose another 2 factors to look at besides defense and speed to explain, but as you can see, there's plenty of other options that you have. But what I am then going to do is I could, and I wanna point out for this assignment, it's completely sufficient for if you just copy this graph into PowerPoint and talk about it. Now, I want to go a little bit step further, and for you, those of you who do want to go the extra mile and really get good at making slides, specifically if that's your weakness, I'm going to show you how to make a much nicer graph in Excel off of this data. And I am going to do that by sampling some of the data that we have here. So if I take our oops. If I take our DF, I will then want to look at defense and speed. I'll take those two. And I'm using the normal Pokemon data frame that's unnormalized, so I can actually extrapolate real information from it. You can use the normalized, but just realize if you do use the normalized data set, you cannot say anything about about the trend line that we're going to draw through it. So then I'm going to choose to take a sample size of 100 from it. And what this will do is it will return a bunch of random Pokemon, and it'll give me their defense and their speed. And for sample size, you just want to make sure that you are using something above 30 to maintain significant statistical significance. But I'm just going to use 100 because that's a good number. That'll give me a lot of data points to work with, but it will not kill PowerPoint when I put that in. And I'm just going to call this Pokemon sample. And so this will .csv. Oh, and I'm going to make this equal to sample from there. So I just saved a C. I'm actually going to do change this to norm, and that will allow me to display the more get a sense of the competitive advantages of the different stats. I'll just have to remember if I run a trend line through it that I am actually looking at that I can actually take the coefficient as a stat value, but I'll just have to remember it as a correlation after it's normalized, and I'll talk about that in a second. But then I can go to Google, I'd go to Google Colab, and I will import files so I can download this CSV file, files.download. And then I'll want to do Pokemon sample.csv. And so then if I run that, I will have my Excel file. So let me go ahead and open that. Okay, and now I have this Excel file, and it shows me the speed and defense stats for all these different Pokemon, and it shows me where they have their stats most distributed. So now what I can do is I can come over here, I can open up my PowerPoint that I have, and I will take this graph, I'll create a scatter plot here. Okay, Okay, and I can go back to that CSV file that we had. And then I'll import that. Okay, I'll add axis titles. I'll take off the grid lines. And then I will call this, let's see. So this is our X. This is our X axis down here. Let's make sure we make these. This is defense. We'll call defense and speed distribution. Okay, we'll call that speed distribution. Wait. No, defense is our X. So we'll call this one defense distribution. Make this size 14. We'll also make this size 14. And then we can go over here to these numbers. I'll make these into percentages so they can show the distributions. Format that to don't want any decimal places. Same goes for here. Then I'll just call this graph stat distributions. Okay, and then I'll draw a tread line through it. Give this tread line a different color so it's a little bit easier to see. Make it a little bit bigger. I'll then go to more options. Display the equation on the chart. So it wouldn't be too bad to also get an R squared value as well. Okay, so looking at this, what does this chart tell us? So there's defense distribution and then speed distribution. So as your defense increases, your speed decreases. So what is the big takeaway that I want to say here? How about this? We will say that if you have a Pokemon that has a lot of speed, if you have a Pokemon that's high on speed, you want to have a move that will increase your defense because that's your weakness. Or if you have a Pokemon that's high on defense, you want a move that increases your speed. So those are your weaknesses. So I will state Pokemon with let's see, with low with high speed are usually weaker in defense and vice versa, thus having a move that increases these stats is greatly beneficial. Okay, so then I can have my key takeaways over here. And I'll just first off say that competitive advantages in speed and defense are negatively correlated. The relationship between the two when normalized using unit vectors, that was the type of normalization that we ended up using, is about negative 0.59, or I'll just say 0.6. And then lastly, Pokemon that have moves that allow them to make up to increase their opposites, or these stats when they have a competitive advantage, and the other can greatly help them cover their weaknesses. Okay. Lastly, to really make this look good, I should add a source or a header where I got this from. So I'll just go back to our URL that we had over here. I'll open this up. This is RESTful Pokemon API. So I'll just add a source as RESTful Pokemon API. Okay, maybe want to bring that down a little bit. Okay, and then I might want to go over here. Might want to bold. Okay, that's quite a bit. Increasing these stats. And I want to bold this over here to point that out. And there you go. That is the end-to-end data analysis. Starting from connecting to an API, coming all the way here to actually get some practical results. Maybe we'll just get rid of this, thus. And so what is really cool about this is actually something that is somewhat practical, or at least more practical than some of the other previous assignments that we were doing, because now you can actually helps inform decision making. This chart analysis that we did helped inform us that if we have a Pokemon that's either that's either high on defense or high on speed, then we should give it a move that increases its defense or increases its speed to help to try to cover for its weakness. And this is analysis that you can take and go to one of your friends that enjoys playing Pokemon and give it to them. Now, with that, think about what the other applications can be to much greater problems or other things that you might deal with in the business world. Really quickly, I do just want to reiterate though that it's perfectly acceptable to just go through and say, take this image right here. If you don't want to go through and do the PowerPoint graph, that's completely fine. It would be completely acceptable to do something, to turn something like this in for the assignment, and then just maybe have like a circle over this to highlight it. And now I'd also want to point out that if you do choose to do the Pokemon API, you'll have to pick two other stats besides, you'll have to pick a different pair of stats besides speed and defense. Now you can do something like defense and attack or speed and HP, but you cannot do the same correlation of speed and defense when turning in your assignments. Lastly, it's that time where we see how well ChatGPT can do this homework assignment. So I'm going to write down, write Python code to connect to let's take that URL that we had, up here. To connect to this API and create a data frame of Pokemon stats. Let's see how ChatGPT does here. Look at that. That's very similar to what we were doing. Wow, that is almost the same function. Okay, so we did something a little bit different. We did while more stats. Okay, I guess using a for loop could have worked as well. Notice that this does not have any of the functions in it. But let's see how that works. Oh, I guess that cleared off our old data frame. But yeah, let's see what this new data frame looks like. Oh, there you go. It did a little bit different. We used name as index. It created a new column called index. But it was able to do basically the exact same thing. Note though, ChatGPT only did the first page. And for this assignment, you need to go through and do all the different pages. But let's see something else. So the extra credit on this assignment is if you do analysis on types. So let's say, can you add types to the data frame? So let's see if ChatGPT would be able to do the extra credit for this assignment. Interesting, look at this. So it gets the different types for T and types. Oh, let's see how this turns out. I'm going to run this. What do you know? Look at that. Now you have types for the Pokemon. However, this is not going to work for your assignment per se because you see this is strings. What you want to do is you can't, since this is a categorical variable, you want to spread it out in dummy variables. So for instance, if this is grass and poison, I would I would drop this types column and I'd have another column called grass, another column called poison, maybe another column called fire over here, one column for each type. And then for Bulbasaur, it would have a 1 in grass and then a 1 in poison to represent that it has those two types, and then a 0 in fire. Now we're going to go over how to do dummy variables in the next assignment. But take a crack at it, see if you can figure it out if you want to get the extra credit for this assignment. But there you go. Please make use of ChatGPT if you have any challenges with this assignment, and please don't spend too much time on it either. You are free to just copy the code that I did if you find that you are spending too much time. So please, this assignment's supposed to be fun, and it's supposed to give you a general sense of APIs, but don't spend more time on it than you need. Okay?